this video, we're going to be talking about reflections and stretch and shrinking a function. So typically, if you have a reflection, you're going to be dealing with negative symbols. If it's on the outside of the function, you have a reflection that is reflecting over the x-axis. So let me write that in, reflects over x-axis. In other words, what happens is whenever there's a negative sign, the function flips either upside down or right side up, just depending on what the function was naturally. But usually it flips upside down if there's a negative sign. And the reason why is because it changes the y value. So like if you had a parabola, let's say x squared, and you put a negative sign in front of it, well, that's going to make it flip upside down, or you can say it reflects over x-axis. So if there's ever a negative in front of the function, like this, it's going to reflect across the x-axis. Now, if you have the negative sign inside the parentheses next to the x, what's going to happen is it's going to reflect over the y-axis instead. Because the reason why is it changes the x values. Where is my pen there? So because it changes the x values, it's going to look like it reflects on the y-axis. So like to give you guys an example, and you can use Desmos. I highly recommend that you use Desmos to really see this, but I'll do my best to kind of doodle what this would look like on a graph. But say you had this function versus the same function, but the x here is a negative. And so they're both parabolas because there's a square outside. But what it will look like, let me see if I can shrink this down just a bit to give myself some space. Go. Is that the first graph, if I were to graph the first one, you might have, actually, let me just do one graph here. Just draw one big graph. The first equation, this one here, might look something like this. Whereas the second equation is going to be on the other side, reflecting across that y-axis. So they look almost like a nice mirror image of each other, reflecting over the y-axis. So in this case, this reflects over y-axis. And so in this case, we're going to take this equation and compare it to its transformation. So like this one has a negative outside. So if you have a negative outside, this is going to reflect or flip over the x-axis. So I'm just going to write here, you can write flipped or reflect, flipped over the x-axis. And to kind of give you a visual here, if I were to draw this graph, typically a square root is going to look like this. If you have a square root function, a positive square root. But if you have a negative square root like this, it's going to go underneath it. And so notice how it reflects across the x-axis when it does that. So it's like flipping over the x-axis. This one here has a negative on the inside of the root. So in this case, it follows the second one where it reflects over the y-axis since it's inside the root. So this is going to be flipped over y-axis. And last but not least, this is quite a combination here. Notice that there's a negative sign here, so I can already say flipped over x-axis. But I also notice the shifts inside. This is a +2 on the inside, so this means left 2. Maybe I should write shift in front. So shift left 2, but also this -3 on the outside means down 3. And there we have it. So in our last concept that we have for our transformation, let's talk about vertical stretch and vertical shrink. So in this case, when you have a stretch, I want you to think of like a graph stretching upwards. And when it does this, typically the coefficient is, actually, I don't think that's how you spell coefficient. Let me go back. Coefficient is greater than 1. And that causes it to be more narrow. So oftentimes people see this as the graph getting skinnier. So let me just pretend like this is the original graph. If something were to have a vertical shift, it might look like this now, okay? Where it's getting skinnier or more narrow. Whereas if you have something that is a vertical shrink, or sometimes people call this a vertical compression, is where you have the coefficient is a value between 0 and 1. And what happens is it looks like it's more wider. And so oftentimes it looks something like this. Like this would be a wider vertical stretch, or a vertical shrink is what we call it. Sorry, I meant to say this would be a vertical shrink, not a vertical stretch. So a vertical shrink because it becomes wider. So that tells me that the coefficient had to have been between 0 and 1. So let's do some practice problem to kind of show this here. So here's my original function. It's an absolute value function. And for part A, it looks like I've put a 3 in front. So let's zoom into that real quick. So if I have a 3 in front, that means that that number is bigger than 1. So if it's bigger than 1, it looks like we have a vertical stretch. So in this case, it's going to get more narrow. Or you can put vertical stretch. But basically, like the absolute value equation is going to get narrow or more skinnier. Whereas this equation right here, has a 1 over 3. So if you were to think about it, that's 0.33, which is a number between 0 and 1. So if I were to think about the vertical, what would happen here, this would be a vertical shrink. In other words, it's going to get more wider. So you can imagine the absolute value sign getting wider or opening up more, because that there is a number between 0 and 1. And that's it, guys, for this video. Hopefully this helps you out with the practice problems below this journal. Bye, guys.